Hi, thanks so much for being here today. In this lesson, you're going to learn how to combine like terms. Now, the question is, what does combine like terms mean, right? So in an algebraic expression or equation, terms with the same variable and or same exponent can be combined. We combine them by adding or subtracting their coefficients. So the key word here is coefficients, okay? So I'm going to give you a total of 3 examples in this lesson, and I'm going to begin with a very practical example to introduce the concept. So that's where I'm going to go next. So the introductory example, you have that Mary has 2 oranges and 3 apples, and Tanner has 4 oranges and 2 apples. And the question is asking how many total oranges and how many total apples do they have. So be careful when you read a question like this one. It's not asking you how many total fruit. It's asking you how many total of each. So I'm giving you pictures here so you can visualize what the problem is asking you. So what I'm going to do is, with these pictures, I'm going to rearrange. So I'm going to have all the oranges on one extreme and all the apples on the other extreme. And the reason I'm doing this is because that's what you do when you combine like terms. Okay, so I'm gonna move all the apples to this side or to the right hand side, and all the oranges will be to the left hand side. And once I've done that, all I have to do is add the oranges together and the apples together, right? So to find how many total oranges we have, or they have, is just add 1, 2, 3, 4, 5, 6. So they have a total of 6 oranges, and apples they have 1, 2, 3, 4, and 5. So the total number of apples and the total number of oranges they have is the following. So the answer to this problem is that they have a total of 6 oranges and a total of 5 apples. And I hope that makes sense to you. Okay, so this is the idea we use for combining like terms. So notice that we're not putting together the oranges and the apples because they are not the same fruit. Okay, that is going to be the same thing with variables and numbers, or variables and variables. So the second example, you will see one variable and then numbers. So if you had to think about what is the coefficient of the oranges, since we have 6 oranges, then we have the coefficient of the orange is going to be 6. And since we have 5 apples, the coefficient of the apples is going to be 5. So 6 oranges and 5 apples. So let's keep that in mind for the next example. All right, so in this example, notice that this is an algebraic expression, and we have 2 x's. So the coefficient of the x's is 2, and then we have a plus 4. So this is a number, right? And then the next one is 3x. The coefficient of this one is 3, and then the number is 2. So this is what I've done to help you understand and make it easy for you to understand what you're supposed to do when you combine like terms. So notice that the x's, I've separated the x's and put them inside of circles. Okay, so these are circles, and the numbers I separated this for as 1 plus 1 plus 1 plus 1, which gives you 4, right? And the numbers are inside of a square. And that is to help me remember that I can't put circles and squares together because they are not the same shape. So I'm going to follow the same method that I did on the introductory example. I'm going to group the circles with the circles and the squares with the squares. And then I'll just add them together. So let's see. So then we have all the circles which have the x's inside of them on the left-hand side of the screen. And then we have all the numbers on the right-hand side of the screen. And that's going to make this easier, or easy to do. Okay. So to find the answer, we just count 1, 2, 3, 4, 5. So we have a total of 5 x's, and then numbers we have 1, 2, 3, 4, 5, and 6. So the answer to this problem is that when you combine like terms, the answer is 5x plus 6. So notice again that I did not add 4x plus 2 plus 3x plus 2, because if I do it that way, then the answer will be wrong. And you might think, well, it should be, this will be 6x, this will be 9x, 11x. But as I said in the beginning, these are not like terms. Just put the x's together and the numbers together as I have shown you with the circles and the squares. And again, I hope that this is beginning to make sense to you. So on the next example, you'll see something different, okay? Instead of seeing variables and a number, you will only see variables, but again, it's the same idea, okay? You use the same concept here. The only difference is that notice that this is 4x squared, so the coefficient of the x squared is the 4 in this term, and this is y, and this is implied to have a 1 in front of it, so that's only one y. And then we have the coefficient of the 3x squared here, is the coefficient is 3, right? And this one is a 4 in front of it, so the coefficient is 4. So what I've done again is I put the x squares inside of circles, and the y's, I put them inside of a square, so that helps me remember that I can't put together the x squares and the y's when I add them or combine them, okay? So again, I'm going to rearrange here, and all I have to do is move this x to this side, and then this y goes right there. And again, just like on the previous two examples, I'm just going to count, because that's what we do when we combine like terms, or that's what we do when we add. All right, so this is 1x squared, 2x squared, 3x squared, 4x squared, 5x squared, 6x squared, and 7x squared. So the coefficient of the x squares is a 7, and then the y's, 1y, 2y, 3y, 4y, 5y. So the coefficient of the y is going to be 5. So the answer to this problem is 7x squared plus 5y. I hope that is making sense to you. Okay? Thank you so much for being here again. Bye-bye.